So getting into today's stuff. Last class we talked about vertical stretch, vertical compression. Today we're going to talk about horizontal stretch, horizontal compression. Both of those are examples of what kind of transformation? Dilation. Okay. As opposed to up, down, left, right, which is translation. So on here it says let's explore the effect of the B value. Make sure you know where that is located. Dealing with quadratics. Okay, that's more what you're going to see in that form as opposed to the transformational function up there. Looking at that first graph, you've got the parent function, which is the one that is in gray, the wider one. And then you've got q of x, which is 2x squared, but written like that. Make sure you know that the 2 is inside the set of parentheses, which makes it the b value. If it was this right here, look at the screen. If it did not have the parentheses, what would that 2 be? The a value. Okay? With the parentheses, that makes it a b value. Coming down to the table. Alright, so this is kind of the big part of this that we're going to look at and trying to find a pattern on what it's actually doing to the x and the y values. So, we're finding the y values that match. So you've got the 4 there, and then you've also got 416 and 216. And then you got 636 and 336. So if I was to write out those points that we have emphasized up there, I've got for p of x, the parent function, I've got 2, 4, 416, and 636. For q of x, I have 1, 4, 216, and 336. So what is happening to the x values whenever that b value became 2?
It was multiplying the x values first, then
Do what?
They got divided by 2.
They got divided by 2. Okay? So the x values, make sure you're writing this down here on B. I don't have room up there on the screen. The x values of q of x are half of what they are in p of x. Alright, so that's what having that b value of 2 is what does that. Going to this next page, so here's the definitions up top. We already talked about this being a dilation. Okay, it's a transformation that stretches or compresses the graph horizontally. Whenever it stretches, I want you thinking that it is stretching it away from the x-axis, as opposed to the a value, which stretches it away from the x-axis, and then compression towards the y-axis, so it makes it look skinnier. So whenever that a value was greater than 1, it was 2, that is a horizontal compress by what factor? Not 2, 1/2. Okay, this is the one where we're going to take the reciprocal of that. So it says, and that's what D talks about, it says, how does the factor of stretching and compressing compare to the B value? All right, the factor is the b value's reciprocal. So let's look at the next example. So now the b value is 1/2 instead of 2. Look at the effect that it has on the graph. Again, your parent function is the gray one. So the one that has the dilation looks wider. So let's do the same thing here. I've got 1, 1 and 2, 1. I've got 2, 4 and 4, 4. I've got 3, 9 and 6, 9. So those are kind of the points that we're looking at and comparing. So in P of X, that is 1, 1, 2, 4, 3, 9. And then in Q of X, the one with the dilation, this was 2, 1, 4, 4, 6, 9. So now looking at the x values, how did the x values change from P of X to Q of X? David? They doubled. So the x values in Q of X are double what they are in P of X. So looking at the back, go to C. So would this be considered a horizontal compression or a horizontal stretch? Stretch, horizontal stretch. It got wider. By a factor of what? Factor of what? 2. All right, on D, it's asking us to compare the two again. So we'll actually write down what it was. The B value in the equation was 1/2. The factor that we used on the x values, okay, they were being multiplied by 2. So that factor is 2. Below that, this is just a quick summary of all that. It does, I feel like they kind of complicated in there. I mean, if it is, it's going to be a horizontal compression if your B value is greater than 1. It's going to be a stretch if your B value is between 0 and 1. I think those rules are a little bit easier to follow. So looking at here, we've seen kind of this picture the last couple class periods, and it's just walking through again the process to graph it, kind of an easy process to graph it. So you're always going to start off with the parent function. From the parent function, you would then graph that vertex. Now this doesn't go up, down, left, or right at all. So my vertex is still at 0, 0. After that, I'm going to plot these other 2 points based off of the reference points. Okay, so since my B value is 1/3, I'm going to multiply my X values by 3 to get those new points, or to get my reference points, and then I will reflect those across to get the full parabola using the axis of symmetry. Okay, so make sure you're good, still good on that process of how to start actually putting it on the graph.
So you would multiply the x values by 3?
So you'd multiply the x values by 3 if the b value is 1/3. So let's go here again, looking at this equation. And I already kind of told you what would happen here, but if this is my equation, the b value is 1/3. I'm going to multiply the x values by 3. And then that's how I would describe the transformations, what I have at the very top of that other column. So go ahead and go down that second column over there, multiplying the x values by 3. Now, if I'm doing this problem, guys, I'm not doing all those points. I'm doing those 4 right there that I have in the red box. Never am I going to actually do that math, apply the transformations to however many, 8 different points. Okay, I'm going to do these. This is still my vertex, and I'm going to reflect those 3 across the axis of symmetry. So now, if going back to what it was originally, if it was 3x squared, that's the equation this one's talking about, I would multiply all the x values by what? 1/3. So go ahead and go through this one and multiply those by 1/3. Those looking down there at the bottom, I'm going to ask you to describe the transformation and by what factor. Okay, so Avery, that first one, A, what would that transformation be? Do what? Okay, is it going to be a stretch or a compress by 4? Stretch. All right, Jeremiah, B.
Horizontal compression.
All right. Daniel, C.
Stretch.
Okay. Jacob, D.
Stretch by 2.
Awesome. All right, then it asks us just to kind of compare the parabolas that we have here. So the widest one obviously is going to be the one that was stretched the most, which is m of x. And then the next one was p of x. And g of x. So those are the 3 that were stretched. And then the one graph that is more narrow than the parent is the one that was compressed, which is v of x. Okay, so going to the next page. So up there it says, now that you studied, now we talked about what B does whenever it's positive, let's talk about what it does whenever it's negative. So referring back to last class though, whenever A was negative, what did it do? Reflected where? Over the x-axis. So if B is negative, it's going to reflect across the y-axis. Then looking here at the table, it already tells you what to do with the points from the parent function right there. You're just multiplying the x value by negative, so you're just changing its sign. And then once you have that, go down there to the bottom to those two little graphs and graph the parent function on the left and then the one with the reflection on the right. And then I kind of want you to draw a conclusion comparing those two graphs. Okay, they both have the same vertex. Meredith, what's up?
They're the same.
Okay, they're exactly the same. So just that reflection really isn't going to change how the parabola looks. Okay? Where this reflection is going to come into play, most of the time, if you look up here, let's say I give you that graph, and then I tell you that I want it reflected across the x-axis, then you would put it right there. Okay? Or sorry, across the y-axis, not the x-axis. So, go ahead and turn to the next page. We're actually going to skip that top one. Over here, this is a good summary of this as well. This has all the exact same stuff as the quick summary before. They've just added that negative b value and what it does at the bottom. So we've now talked about all the transformations that we're going to talk about. So depending on where the a, b, c, and d value are, you need to know whether or not those are going to affect the x or the y values and how they're going to affect them. Okay, so Gavin, the a value, is that going to affect the x or the y value? The a value. The y. Am I going to multiply the y value by a or add or subtract a? Do what, Daniel? Multiply. Okay. Whatever number is in the equation, that's what I'm going to use whenever I multiply by a. All right, Alvin, the B value, is that going to affect the X or the Y? The X. So, and this is kind of weird because there's letters instead of numbers, but if I have a B value, which is a whole number, I'm going to multiply X by what? The inverse or the reciprocal. So it's going to be 1 over B. So if it was 3, it'd be 1 over 3. Okay. Alessandra, the C value, is that going to affect the X or the Y values? X. If it's minus C, am I going to add or subtract the C value on the X? Add. Then Julia, the D value, if it's plus in the equation, am I going to add or subtract it on the Y value? Thanks, Julia. Your voice has changed since the last time we've talked. Alright, so make sure you know, remember all that, and if you recall, whenever we really started talking about transformations a while ago, I talked about everything on the inside. I kind of compared that to the Stranger Things show, okay? Or it's kind of weird. You never actually use the numbers that's in the equation. And that all affects the X value. Everything that is on the outside, you use those numbers, and they affect the Y value. Let's go ahead and flip over to the next page. Yeah, I'll do that. Alright, so pay attention to this. Okay, we won't see a lot of this, but it is fair game. So you've got two people that are talking about the transformations for that equation. This first person, they see this. Okay, that X has a coefficient to it, which we have not seen this yet. They factor that 3 off of the 3X and off of the 12, and they're left with X plus 4. Okay, that 3 is the B value. If you remember, whenever we were writing the transformations, write that a little bit cleaner. Okay, that part of it at least. The B value is always located in between two sets of parentheses. So if it is not set up like that, then you need to make it look like that by factoring out that coefficient. So they factor that out. They get the X plus 4. They say, okay, it's going to go 4 units to the left, as opposed to the person over on the other one. They say that it is going to be 12 units to the left, which is incorrect. All right, we won't see a whole lot of that, but you will see. You could possibly see it. So with that, let's come down here. And let's go ahead and graph those values for this equation. So the first thing I want to do, if my B value is 3, I'm going to multiply all my X values by what? 1/3. And I'm also going to do what to them? David, what else am I going to do to them? If it's X plus 4, which direction is that going to move?
To the left.
So if they're going to go to the left 4, I need to take all my X values and do what to them?
-4.
So if I know I haven't changed any of my Y values, that makes it easy. They're all going to stay the same. And then I would apply all that, the multiply by 1/3, subtract 4 to those. Go ahead and add the 0.39 at the bottom. Never mind, that won't fit on the graph. We don't have to do that one. Once you got those, go ahead and graph them. So I've got negative 4, 0. Be careful with the values on the x and the y-axis here. I messed this up the other day. Both of them are going by 1/2 increments. No, that's right.
Why did you write -3 1/3 2 times?
The first one is 2/3. Whenever you're done with that, go ahead and flip it over. No, we're not going to do that. Okay, go to page 227. So this is just a big summary of all of the transformations that we've talked about. Okay, so if I was to study for the quiz that you have next class, I would make sure that you know all these rules. Okay, so first looking at the d value, the number at the very end of the equation. If that d value is positive, which direction is that going to move the graph? Up. And so a negative d value is going to move it where? Down. Rachel, if the c value is positive, so x plus c, which direction is that going to move it? Left. And so obviously minus c is going to move it to the right. Avery, if the a value is greater than 1, what is that transformation going to be? If it's a, is it vertical or horizontal? Vertical. If it's greater than 1, is it going to be stretch or compress? Stretch. And now if it is between 0 and 1, it is going to be a vertical. It's going to vertically compress. Dalton, if a is negative, it's going to reflect across which axis?
Reflect across the x.
Daniel, if the b value is greater than 1, that is going to horizontally what? Compress. Those rules are different between the a and the b value. And so obviously, if it is between 0 and 1, that is going to be your stretch. Then Jeremiah, if the b value is negative, it's going to reflect across which axis? the y-axis. Alright, now just so I can leave this up here, since some of you still writing it down, below this table, just so that you have, I think it would be good to have all of this on the same page. Go ahead and write this for me. And I would write that down there.